Okay, now finally let's do another limit definition of the derivative. So we want to do f prime of x equals the limit as h goes to 0 over f of x plus h minus f of x all over h. So again, this all boils down to algebra. You are all algebra experts because you wouldn't be in this class if you hadn't passed algebra. So you are awesome. All right, so now we're going to plug in x plus h. So that's going to be 2x plus h squared minus 3 times x plus h minus 2x squared minus 3x all over h. Okay, so that's the setup. Now we have to do the algebra. So everyone can do the setup, right? Because it's just plugging stuff in. So now we're going to square this out and then multiply it by 2. So I'm going to kind of do this in one step. X plus h, I'm not. So that's going to give you x squared plus 2xh plus h squared minus 3x minus 3h minus 2x squared plus 3x over h. Okay, now look, 3x's and the negative 3x and the positive 3x cancel. So now we're going to get the limit as h goes to 0, and we're going to distribute that too. So 2x squared plus 4xh plus 2h squared minus 3h minus 2x squared all over h. So the 2x squared vanishes. And now look, you know you're right if every term has an h in it. Does that have an h in it? Yes. Does that have an h in it? Yes. Does that have an h in it? Yes. So that means we can now cancel out the h's. So that's going to give us the limit as h goes to 0. Now be careful. That's going to give me 4x, but we also have to cancel out with one of those and then one of those. So plus 2h minus 3. And then as h goes to 0, that's going to give me 4x minus 3. Now you're all thinking, oh, that's a lot of work. Isn't there a shorter way of doing the derivative? I seem to remember one of my friends telling me about a cool rule that allows me to take the derivative without doing all this work. And that's what we're going to do next module. And there we go. Bye.